The USA has been hit by a series of powerful hurricanes, with Hurricane Helen and Hurricane Milton striking back to back, leaving devastation in their wake. Coastal states are reeling from the impact. But why are these storms hitting so frequently with such force? In today's video, we will first understand how hurricanes are formed, science behind these extreme hurricanes, and why we are seeing such intense storms. Let's first have a look at the states that were most affected by the hurricanes. The states most affected by Hurricanes Helen and Milton include parts of the Gulf Coast, Florida, Texas, and Louisiana, along with the Carolinas. While Hurricane Helen made landfall first, bringing heavy winds, rain, and flooding, Hurricane Milton followed shortly after, delivering even more destruction. Cities like New Orleans and Houston were hit particularly hard, experiencing severe flooding, power outages, and major infrastructure damage. So why we are seeing such hurricanes like Helen and Milton striking one after the other? So let's first understand what are hurricanes. A hurricane is a powerful and large storm system that forms over warm ocean waters, primarily in tropical regions. It is a type of tropical cyclone which includes storms like typhoons and cyclones. All are essentially the same weather phenomenon but are called different names depending on where they are formed. In the Atlantic and Northeast Pacific Oceans, we call them hurricanes. For hurricane formation, there are several conditions that need to come together. First, we need warm waters. First, the warm water heats the air above it, causing it to rise. The rising air then creates a low pressure system at the surface. As the warm air rises, it cools and condenses into clouds, because when they rise, the temperature above is less, so they cool down and then they condense into clouds and thunderstorms, releasing heat that further fuels the system, and this cycle goes on. As the system strengthens, it begins to rotate due to the Coriolis effect, which is caused by the Earth's rotation. When the winds around the center reach 74 miles per hour, the storm officially becomes a hurricane. So this is how a hurricane is formed. Key characteristics of hurricanes. First is warm ocean waters, at least 80 degrees Fahrenheit to form. The heat and moisture from the ocean fuel the storm, allowing it to grow and intensify. Second is the rotating wind. Hurricanes have rotating winds spiral inwards, forming a circular pattern. These winds can range from 74 miles per hour for a category 1 to over 157 miles per hour for a category 5. So this is how we categorize the hurricanes. As the storm strengthens, its winds become more dangerous. Third is the low pressure system. At the center of a hurricane is a region of low pressure system. This is called the eye. The eye is calm, but the surrounding eye wall has the storm's strongest winds and heaviest rainfall. So the eye is calm, cause the most destruction. And fourth is rain and storm surge. Hurricanes bring intense rainfall and often cause storm surges, which is a rise in sea level due to the hurricane's wind pushing ocean waters towards the shore. This can result in dangerous coastal flooding. Hurricanes mostly occur in the Atlantic Ocean, Gulf of Mexico, Caribbean Sea, and the Northeast Pacific Ocean. The hurricane season runs from June to November, with the peak happening between August and October. So why are we seeing hurricanes like Helen and Milton striking one after the other? One of the main reasons is the current climate conditions in the Atlantic. This year we have seen warmer than usual ocean temperature, which fuel hurricanes, giving them more energy to intensify quickly, and a weaker wind shear, which usually helps break up or weaken storms. Without it, hurricanes are able to grow larger and stronger. These climate factors created the perfect conditions for both hurricanes to form rapidly and intensify before making landfall. Scientists are also pointing to the climate change as a major reason behind the increased frequency and strength of hurricanes. Warmer ocean waters acts like fuel for these storms, allowing them to grow stronger in a shorter period of time. This explains why Hurricane Milton intensified so quickly after Hurricane Helen. Additionally, rising sea levels mean that storm surges are becoming more dangerous, leading to more coastal flooding. This has worsened the impact in states like Florida and Louisiana, where many areas are already close to sea level. While Hurricane Helen was devastating, Hurricane Milton was on a whole different level. Milton not only had stronger winds but also covered a much larger area. Helen brought wind speeds up to 170 miles per hour, but Milton shattered records with over 200 miles per hour winds. This led to catastrophic damage to homes, power grids, and infrastructure across a much wider swath of the country. The back-to-back nature of these storms meant that states already weakened by Hurricane Helen were left even more vulnerable when Hurricane Milton hit just days later. When comparing size, Hurricane Helen was more compact, which focused its destruction in a narrow region. It spanned around 400 miles in diameter, which is still a massive storm, whereas Hurricane Milton was a giant in comparison, stretching over 600 miles wide. This gave Milton a far larger reach, impacting more areas simultaneously from coastal cities to far inland regions. Helen's compact size meant it had more intense winds in a smaller area, but Milton's broader size meant more widespread damage across entire regions. Now let's talk about one of the most important factors in a hurricane strength, that is central pressure. The lower the pressure, the stronger the hurricane. Hurricane Helen had an incredibly low pressure of 910 millibars at its peak, making it a fierce storm. But Hurricane Milton, its central pressure dropped to an insane 880 millibars, which is one of the lowest ever recorded. So you can see that Helen at the peak had low pressure of 910 millibars, whereas Milton with starting low pressure 880 millibars, which fueled Milton's record-breaking wind speeds and massive size. And this was the reason that it became a Category 5 hurricane from a Category 2 in just under 12 hours. This rapid growth caught many by surprise, making both storms difficult to prepare for. These hurricanes had unpredictable paths too. Looping back, changing courses, taking unexpected turns, kept meteorologists on edge. This unpredictability added to its danger as evacuation plans had to constantly shift. So it's important to note that both Helen and Milton are part of a new wave of stronger storms, likely influenced by climate change. Warmer ocean temperatures and higher sea levels provide more fuel for hurricanes, allowing them to become more intense. While Hurricane Helen was one of the strongest storms of its time, Hurricane Milton is part of a growing trend of hurricanes becoming stronger, bigger, and more dangerous. So when comparing Hurricane Milton to Hurricane Helen, both were incredibly powerful, but Milton takes the crown for the strongest hurricane. Its record-breaking wind speeds, massive size, extremely low pressure, and rapid intensification makes it a storm for the history books. Helen was intense, but Milton redefined what we thought was possible with hurricanes. With these intense hurricanes becoming more common, experts are warning that we may need to rethink how we prepare for hurricane season. This could mean upgrading building codes, improving flood defenses, and investing more in climate change adaptation. The back-to-back strikes from Helen and Milton are a stark reminder that we are entering an era where extreme weather events could become more frequent and severe. As we continue to face these back-to-back hurricanes, it's clear that we need to adapt and prepare for an era of stronger and more frequent storms. If you found this video helpful, like, subscribe, and hit the bell icon for more such videos. Thanks for watching.